Good morning, my chickadees. I'm so happy to see you today on May the 4th. Be with you, Star Wars Day. I love today. I love Star Wars. It's so much fun, and the battle between good and evil. So true. So true. And today is actually my best friend Jenna's birthday. So here we go. On three. 1, 2, 3. Happy birthday to you. Happy birthday to you. Happy birthday, dear Jenna. Awesome and musical and amazing and funny and super duper generous and beautiful Jenna. Happy birthday to you. Mwah! All right, but let's keep going, chickadees, because this is actually math class and not birthday singing class. Okay, so here we go. Please make sure to take your pencil, put today's date, May the 4th of the year 2020, and your name on the top of your page. This is so important. And please put your name and date at the top of the page and make me so happy. Okay, here we go. Today we begin graphs. Now we've seen graphs in history, all right? Have we seen any graphs in science? I don't know. I think mostly history. Okay, so we begin with a pictograph. Picto. Picture, a graph made of pictures where they insert little drawings and each drawing stands for a certain amount of a thing. So kind of some maps are like pictographs, okay, because they have little pictures that symbolize different things and they put those little pictures in certain places. Now when you take the pictures and put them in a graph, the graph can be vertical and the graph can be horizontal. Either one is valid. Then it's a pictograph. Okay, so today's pictograph is about frogs in Feddo's house. So take a look at the bottom in your yellow box. The scale, or the key, the scale says each frog means 10. So each picture we see on the graph stands for 10. So we better be counting in tens. Great job. Okay, so you got the bedroom, you got the kitchen, you got the throne room, and you got even in the closet. You know how the Bible said they could not take a single step without touching a frog? They were everywhere. Oh my gosh, I think about trying to go to the bathroom or trying to shower with frogs everywhere. Trying to cook, they're getting into your food. And what if you don't want to eat frogs' legs? They're very tasty, but you're not always in the mood. Okay, so here we go. We're going to answer the questions in section number 1. How many frogs were in the bedroom? Now remember, take a look at the scale. It says each picture means 10 frogs. So let's count by tens. In the bedroom, there are 10, 20, 30, 40, 50, 60 frogs. So the answer to number 1A is 60. B, how many frogs were in the kitchen? Remember to count by tens. 10, 20, 30, 40, 50. Booyah. How many frogs were in both the throne room and the closet? Both is a clue word for addition. So let's add those two together. 10, 20, 30, 40, 50, 60, 70. Bleh. Blah, 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 blah. How many more frogs were in the kitchen than in the closet? Okay, so what I'm going to do is I'm going to take a look at the graph. I'm going to see where the closet ends, and then I'm going to keep counting in the kitchen. 10, 20. There were 20 more frogs in the kitchen than in the closet. Well, I think that's possible because usually the kitchens are bigger than the closets. Unless it's my dream home, and they might possibly be the same size. Humongous. Okay. You're gonna have a lot of costumes. How many times as many frogs were in the bedroom as in the closet? Oh. Times. Times means multiplication. Okay, so there's 1, 2, 3, 4, 5, 6 frog pictures in the bedroom and 1, 2, 3 frog pictures in the closet. So how do you turn 3 into 6? Times 2. Very good. That's how you would do that. There are 2 times as many frogs in the bedroom as there were in the closet. And last question, how many frogs were in all 4 rooms? Count them up and put a 0 at the end. When you multiply by 10, all you have to do is put a 0 at the end of the other number. So let's count the frog pictures and put a 0 at the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 with a 0 behind it. 180 frogs total in Pharaoh's house. Yuck. I actually think that each frog should stand for 100 or 1,000. I think Pharaoh's house is pretty big. Okay, that is your introduction to pictographs. Tomorrow we're going to do some more work with pictographs. We are moving on to section 2. I have on my board already 2A and 2B. This is where we are multiplying fractions and mixed numbers. And we are also going to multiply a mixed number with a whole number. We need to turn everything into fractions. Everything must become a fraction. Now, here we go. We turn that first number in 2A into a fraction just by placing the number 1 below it. 5 over 1 is a valid fraction for multiplication because 5 divided by 1 equals just the whole number 5. Ooh yeah, ooh yeah. And then we need to use our formula to turn our mixed number into a fraction. Whole number times denominator, add your numerator all over your denominator, okay? So here we go. In parentheses, 4 times 7 plus 6 all over 7. That equals 4 times 7 is 28, plus 6 is 34, all over 7. Okay? And so now I'm going to rewrite my equation. 5 over 1, turning that whole number 5 into a fraction, times 34 over 7. Cross cancel. 34 and 1, you can't cancel anything. 5 and 7, you can't cancel anything. So we're just going to have to multiply across numerator times numerator and denominator times denominator. Oh, 5 times 34. So 5 times 4 is 20, carry the 2. And 5 times 3 is 15, plus 2 is 17. All over 1 times 7 is 7. Oh my gosh. Oh my gosh, oh my gosh, oh my gosh. I get that. Okay, so now we have to reduce because our numerator is larger than our denominator, which means we need to divide down, okay? So, I'm coming down. 170 divided by 7. 7 cannot divide into 1. Both 7 can go into 17. My guess is 2. 2 times 7 is 14. 17 minus 14 is 3. 3 is less than 7, so I can bring down. 7 into 30, my guess is 4. 4 times 7 is 28. 30 minus 28 is 2. Oh, you can't see that anymore. 2 is less than 7. And then I turn my remainder into a fraction. So my remainder becomes my numerator and my divisor becomes my denominator. So my final answer for 2a is 24 and 2/7. Woo-hoo! Is that right? That's right. Yeah! I love getting it right. It feels so good. Okay, so I'm going to erase this division work. If you need to see it again, you can rewind the video. 21st century pandemic school. Okay, here we go. I'll just stay on my knees. Okay, it's a good place to be when you need something from God. Help me. All right, our first number is already a fraction. We don't have to change anything about that. Our second number is a mixed number. We need to turn that into a fraction using our formula. Whole number times denominator plus numerator all over denominator. Here we go, 1 times 2 plus 1 all over 2. That becomes 3 over 2 because 1 times 2 is 2 plus 1 is 3. And then I rewrite my equation below. That original 4/5 times 3/2. Check if you can cancel anything. I already see it. I see it already. 4 and 2 I can cancel by dividing by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. Can I cancel anything in 3 and 5? No. So now I'm ready to multiply across. 2 times 3 is 6, and 5 times 1 is 5. This is an improper fraction. Numerator, denominator, divide down, okay? So 6 divided by 5, we pretty much have that ability to do that in our head. We know that's going to be 1 and 1/5. So our final answer is 1 and 1/5. Circle it. What is 4/5 of 1 1/2? Well, that's 1 and 1/5. Fractions. Cool, man. All right, I'm going to do 2 more with you, and then I'm going to leave the rest. I'm going to do C and no. I'm just going to do E. I'm just doing E, okay? So here we go. I'm erasing these. We're dropping down to 2E, okay? This has got a kind of fun, special answer. All right, so the equation. 5 times 3 and 2/5. 5 times 3 and 2/5 equals. So here we go. I turn that first whole number into a fraction by placing it over the number 1. Okay, that's how easy that is. Over 1. That's it. That's all you got to do. And now I turn 3 and 2/5 into a fraction. My whole number 3 times my denominator 5, adding my numerator 2 all over the number 5. 3 times 5 is 15, plus 2 is 17, all over the number 5. And now I rewrite my equation. Can you see that? Yeah, you can still see that. 5 over 1 times 17 over 5. Oh, can we cancel? I think we can. 5 and 5, that becomes 1 and 1. 5 divided by 5 is 1, and 5 divided by 5 is 1. 1 times 17 is 17, and 1 times 1 is 1. This is an improper fraction. All we have to do to turn it into a whole number is the opposite of what we did here. We place the 1 underneath the 5, and all we have to do is erase the 1. Our answer is the whole number 17. oh, 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 oh. We're good at math. Yeah! Love it. Oh my gosh. So please do C, D, F, G, and H in your book. You